Hello everyone! Today's joke of the day is, why does a milking stool have only 3 legs? Stay tuned to find out. Our learning target for today is I can identify slope and the y-intercept from slope-intercept form. Also, I can graph an equation in slope-intercept form. Today we are going to be introducing something called slope-intercept form. This form is great for helping us graph linear equations. Okay, our slope-intercept form is y equals mx plus b, and that's m times x plus b, in which case m is our slope. Okay, that's the slope of our line. As we learned earlier, m represents the slope. That's the letter that we use to represent slope. And then b is a little bit new. That is what we call our y-intercept. Okay, and our y-intercept is where our line intersects the y-axis, or intercepts the y-axis. Okay, so let's look at a few equations and identify the slope and y-intercept. Okay, so for this first one, we have y equals 4/3 x minus 2. Well, if we look back at our formula, the slope is the number that we multiply by the x. So we're going to have our slope, which is m, is equal to 4/3. And our y-intercept is b. Okay, so that's the thing that comes afterwards. And in this case, it looks like it's going to be 2, but actually we have to take the sign that's in front of the 2, so it's actually going to be -2. Okay, so make sure you're careful there. If you have a negative number, or if you're subtracting what your y-intercept is, that makes your y-intercept negative. Okay, let's look at another example here. We have y equals -7x plus 8. So again, this will be our slope. That will be the number that's multiplied by our x value. So our slope is equal to -7. Again, taking that sign that's to the left of our number. And our y-intercept, which is b, will be equal to, in this case, a +8. So we can just write 8. Okay. Now this equation, y equals x, is a little unique in a couple of ways. First of all, if we don't have a number in front of our x there, in front of our variable, we can always assume that our coefficient is going to be 1. Okay, so in this case, our slope is equal to 1. All right. We also don't have anything over here. Okay, we're not adding or subtracting any numbers, so that's really like we're adding 0. Okay, so adding 0 is the same as not really doing anything to that number. Okay, so in this case, our y-intercept is going to be 0. Okay, our slope is 1 and our y-intercept is equal to 0. All right, let's look at one more example here. We have y is equal to -3. Okay, well in this case, we don't have a variable. All right, it looks like, so we would want something in the form of y equals mx plus b, right? But here we don't have that mx, okay? Well, what number would get rid of an x, right? What number can we multiply by x to make it go away? Well, 0. So if we had y equals 0x plus, or I guess in this case, -3, that would be the same as y equals -3 because this 0x would just go away. Okay, so now that we've written it in y equals mx plus b form, we can identify that our slope is going to be equal to 0 and our y-intercept is equal to -3. Okay. Now we're going to do the opposite. We are going to write an equation for a line with a slope of 5 and a y-intercept of -2. Okay, so we could write that our slope, which is m, is equal to 5, and our y-intercept, which is b, is equal to -2. So then when we write our equation, we'll get y equals m times x, which is our slope, times x, which is 5x, plus our y-intercept, which would be plus a -2, or would be the same as -2. Okay, so our equation for that line is y equals 5x minus 2. Right? Let's write an equation for a line with a slope of 0 and a y-intercept of 2. Okay, well in this case we'll have m equals 0 and b will equal 2. Okay, and if we're going to write it in y equals mx plus b, we'll have y equals 0x plus 2. but our 0x will just go away. So we'll end up with y equals 2. And that is our equation for that line with a slope of 0 and a y-intercept of 2. Okay, finally, write an equation for a line with a slope of 1 and a y-intercept of -4. Okay, so we'll have m equals 1 and b equals -4. Okay, so our equation will be y equals 1 times x plus -4 plus our y-intercept. Okay, let's simplify this out a little bit. 1 times x is really just x, so we can just have that x there. If we're adding a -4, that's the same as subtracting 4. So this would be the simplified form, y equals x minus 4. Okay, now that we know a little bit about the different parts of our equation, or of our linear equation, the slope and the y-intercept, we are going to look at graphing linear equations from slope-intercept form. Okay, so here if we want to graph the following equations, let's look at this first example. We have y equals 2x minus 3. Okay, well, y equals 2x minus 3, we can identify our slope is going to be 2, and our y-intercept is equal to -3. Okay, so right away, when we're going to graph this line, we can think that our y-intercept is at -3, so on our y-axis, we will put a point at -3. Okay, our y-intercept is -3. This is really the point 0, -3. Okay, 0 in the x, -3 in the y, right? And if we remember back to m, our slope is equal to our rise over our run. Okay, well in this case we just have 2, which we can say is equal to 2 over 1. Okay, so for every 2 spots we go up, we're going to have to go over 1. Okay, so we can start at -3 and we'll go up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, we could also go the other direction and go down 2 and to the left 1. Right, down 2 and to the left 1. And that looks like enough points to graph our line, so we'll just draw our line through all of those points. Okay, and we graphed our line from slope-intercept form. All right, let's look at another example here. In this case, we have our slope, m, is equal to 3/4, and our y-intercept, b, is equal to 2. Okay, so we know that at 0, 2, we can place a point because that's our y-intercept. This is really 0, 2, that point. Okay, and then for every 3 numbers we go up, so this is 3 is going to be equal to our rise, and 4 is equal to our run. Okay, so for every 3 spots we go up, so we'll go up 1, 2, 3, and then we'll go over 1, 2, 3, 4. Okay, so we'll go right there, and we'll go up 3, 1, 2, 3, over 4. 1, 2, 3, 4. All right. We could also go the opposite way. We could go down 3, 1, 2, 3, and then to the left 4, 1, 2, 3, 4. Okay, and that gives us enough points to probably draw our line here. Okay, our slope is definitely less steep than our last one, but there we go. Okay. Now in this case we have a negative slope. We end up with our slope m is equal to -1/2, and our y-intercept b is equal to 8. Okay, this would be then the point 0, 8. Okay, so let's go up to 0, 8, and we'll place a point there on our graph, and that's always easy to be our starting point. Okay, well in this case we have -1/2 is our slope. So we can think of this as being equal to -1/2, right? Down 1 over 2 to the right, or +1, up 1 to the left 2. Okay, either of those things. I'm going to focus on this one for right now. So if we go from 8, we go down 1, we're going to go to the right 2. Okay, so you always have to make sure that if your number is negative, one of your, either your x or your y is decreasing, or like going down, or to the left, and then the other one is doing the opposite. Okay, so here we go, down 2, or no, sorry, down 1, over 2. Okay, down 1 over 2, down 1 over 2. Again, though, we could go up 1 and to the left 2 as well. And this looks like it makes sense. Oh, that was really bad. This makes sense because it looks like our line, the slope of our line is negative. Okay, we're going down and to the right gradually, so we know that we graphed it correctly. All right, you might also come across one of these types of equations that doesn't have a slope, right? In this case, we don't have anything here, so we know that we have 0x. Okay, so our slope here is going to be 0, and our y-intercept is equal to -2. Okay, so in the case that our slope is 0, that's thinking like, okay, we are going up 0, right? Our rise is going to be 0, and our run will be anything. So let's start with our point here at 0, -2, okay, where our y-intercept is 0, -2, okay? And for whatever, any y value that we, or any x value that we would use, okay, so say that we wanted to use x is 4. We would take 0 times 4 minus 2. Well, that would give us -2, okay? And that would be true for all x values, okay? It's not changing at all because we don't have that variable in there. So really, we can just draw a horizontal line. Okay, and this makes sense because horizontal lines have a slope of 0. So if we have an equation that has a slope of 0, then we know that we're going to have a horizontal line. All right, let's look at one final example here. X equals 3. Okay, in this case, we don't have a y value at all. We don't have a y anywhere in there. This doesn't really look like a linear equation. But in fact, it's saying that for any y value, okay, x is always equal to 3. So we'll start here with x equal to 3 on the x-axis, okay? But really, like, the x is always going to be equal to 3. So x will be equal to 3 there, and down there. And this will give us a vertical line. Okay, so x being equal to a value will always give us a vertical line, all right? Okay, so for today's joke of the day, why does a milking stool only have 3 legs? Well, because the cow has the udder. Thanks for watching and have a great day.